Hello, geometry students. I hope you are having an awesome day. We're going to do our 5.1a notes, angles of triangles. And the reason why we're splitting 5.1 into two pieces is that the book assumes that you already know everything there is to know about classifying angles. And although I'm sure that you probably have learned this before, I wanted to just give you an opportunity to review and solidify your learnings. So there's two basic ways to classify angles. The first is to classify by angles. So let's write that down. At the top we have 5.1a, angles of triangles, and then underneath that I've written classify by angles. Now there's four different ways that we can classify a triangle by its angles. The first is a right triangle. A right triangle. So can you remember what has to be true in order for a triangle to be a right triangle? There needs to be one 90-degree angle. So let's write that as a note. It has one 90-degree angle. And then let's draw a picture of that. And we're going to show that triangle with a box in the corner, and that is a 90-degree angle. So that's one type. Okay, and then what would be another way we could classify a triangle? I think that we've used these words already, but just to have everything in one spot. Do you know what another way of classifying by an angle might be? We can have an acute triangle. With an acute triangle, the triangle has all 3 degrees less than 90. So we've talked about an acute angle. An acute angle is less than 90 degrees. An acute triangle would be a triangle where all 3 angles are less than 90. So for example, let's just draw a picture here. Now we're not going to put a box in this one, but we could have 80 degrees, 70 degrees, and 30 degrees. They do need to all add up to 180, so 70 plus 30 would be 100, plus 80 more would be 180, but that triangle would be acute. Then we can also have an obtuse triangle. Can you remember what obtuse means? Think about an obtuse angle and see how that might apply to triangles. An obtuse triangle is a triangle that has one obtuse angle. That means one angle that's more than 90 degrees. So for example, we could have a triangle that has angles of 110 degrees, maybe 50 degrees, and 20 degrees. That would be considered obtuse. Now, most of the time we're going to use one of those 3 words, but sometimes we call a triangle equiangular. Equiangular. So can you guess what equa means and what angular means, and then guess what equiangular means? Equiangular means equal angles, or all 3 angles are the same. So an equiangular triangle is a triangle that has 3 60-degree angles. Now the reason this works out, and we're going to talk about this more in our next notes, is that all the angles of a triangle have to add up to 180. So if they're all going to add up to 180 and they're all going to be the same, the only way to make that happen is if each one is 60 degrees. So an equiangular triangle is a triangle that has 3 60-degree angles. So that's how we would classify a triangle by its angles. Now we're going to talk about how do you classify a triangle by its sides. How do you classify a triangle by its sides? So we're going to write at the top, classify by sides. Okay, so there's 3 basic ways we can classify by sides. The first one is a scalene. That's spelled S-C-A-L-E scalene triangle. Do you remember what that means? What is a scalene triangle? A scalene triangle has sides of 3 different lengths. So it has 3 different side lengths. Now, when we draw that triangle, we can kind of show the triangle like this. And maybe the angles, the sides look like they're different, but we can show that they are by putting 1 hash mark on one side, 2 hash marks on another side, and 3 on the third. If there's a different number of hash marks on each side, then it means that the sides are 3 different lengths. That would be a scalene triangle. The next one would be isosceles. Isosceles triangle. Do you happen to remember what that means? With an isosceles triangle, there are at least 2 congruent sides. So at least 2 congruent sides. Remember that congruent means the same length. So for an isosceles triangle, we might have something like this, where those 2 sides are the same, but the third side is not. That would be an isosceles triangle. And by the way, we'll talk about this more as we progress through this chapter, but if a triangle is scalene, if all 3 sides are the same, then it is always going to be the case that all 3 angles are the same. And if a triangle is isosceles, which means 2 sides are the same, it will always be the case, and this is a good fact to know, that the 2 base angles across from those sides, they will also always be the same. So you can tell something about the angles by looking at the sides and vice versa. If you look at the sides, you can know about the angles from the sides or the sides from the angles. All right, let's look at an equilateral triangle. Equilateral. So again, think about what equal might mean and lateral might mean. An equilateral triangle is a triangle with 3 congruent sides. So the way we would show that is by drawing a triangle with, for instance, 1 tick mark on each side. Now again, just like I talked about in the other 2 examples, if it's equilateral, it's also going to be equiangular. So the pattern does go both directions. All right, now we're just going to do 2 examples now that we've done this part of the notes. So there's only 2 examples on these notes, but I purposely picked examples that are a little bit harder because that way if you have more instruction on the harder ones, it'll be easier for you to do those later. The easy ones we can easily handle during Zoom. So let's do example number 1 here. Example number 1. Find the measures of the legs of isosceles triangle ABC if. So I'm hearing that, isosceles triangle ABC, and I'm thinking, you know what? I'm going to draw a picture. So I'm going to draw a triangle and I'm going to write ABC. And because I know it's isosceles, I'm going to put tick marks on each side. Now, we don't necessarily know, based on the information we've read so far, that these are the 2 sides that are congruent, but we will find that out in a minute. This is giving me a visual to work with. Now it says, if AB equals 2x plus 4. AB equals 2x plus 4. What does it mean when I have 2 capital letters right next to each other? That means distance between A and B. So this side I can label as being 2x plus 4. And BC is equal to 3x minus 1. So from B to C is 3x minus 1. And then it tells me that AC equals x plus 1. So this is x plus 1. And the perimeter is 34. P equals 34. So who can guess, if this is our diagram, we know the triangle has a perimeter of 34, and I've labeled the lengths of all 3 sides, what would be my equation that I would set up to solve for x? Think about what perimeter means and what information you have. what I would want to do is add up all three sides and set them equal to 34. So I'm gonna take 2x plus 4, I'm gonna add it to 3x minus 1, and then I'm gonna add x plus 1 and set everything equal to 34. Now I need to combine like terms, so the 2x plus the 3x plus one more x would be 6x. 6x. 4 minus 1 is 3, plus 1 is 4 again, so we have 6x plus 4 equals 34. The opposite of adding 4 is subtracting 4, so I have 6x equals 30. Then when I divide by 6, I get x equals 5. Now, the question said, what are the measures of the legs of the isosceles triangle? So we need to know all three sides. If x is 5, to find the length of AB, I can take 2 times 5, which is 10, plus 4 more, and get 14. So this side length is length 14. For BC, I can take 3 times 5, which is 15, minus 1, and also get 14. So this side here is also 14. And for the third side, it's x plus 1, so 5 plus 1 would be 6. Let's see if that adds up to 34. When I take 14 plus 14, I get 28, plus 6 more is 34. So everything checks out. That's how you would do this example. Now, we just have one more example, and there will be ones like this on the homework and possibly also on your test, is it says to classify triangle OPQ by its sides. If O is at 0, 0, so let's go ahead and put that down. We have O at 0, 0. P is at -1, 2. So let me go to the left 1 and up 2 and put a P, and I'm going to write -1, 2. And Q is at 6, 3. So I'm going to go 6 over. 1, 2, 3, 4, 5, 6, and 3 up. 1, 2, 3 up. And that is going to be Q at 6, 3. Now this problem takes a little bit of time. This would be an A level on the test. But if you're wanting to do well on your test and to get the A levels correct, this would be a great problem for you to make sure to listen to and to copy down. So we're supposed to classify by its sides, then determine whether it is a right triangle. So let's classify by the sides first. Let's find the distance between O and P. Now remember, anytime we're finding the distance formula, we need to take the square root of y2 minus y1 squared plus x2 minus x1 squared. And I can label this point x1, y1, and this x2, y2. You could also do Python. That would totally work as well. And maybe I'll do that on one of the next ones. Let's do this one using the distance formula. I would have 2 minus 0 squared plus -1 minus 0 squared, or 2 squared plus 1, 2 squared plus, let me not skip a step, plus -1 squared, which is 4 plus 1, or 5. So the distance between O and P is the square root of 5. Let's write that down here, square root of 5. And you know what I think I'm going to do? I'm going to put it in pink so that it stands out a little bit more. Square root of 5. There we go. Okay, let's find the distance now from P to Q. P to Q. I'll use the distance formula one more time, and then we'll do Python for the last one. So if we're going from P to Q, let's label P and Q with X's and Y's, 1s and 2s. The distance formula is going to tell me to take 3 minus 2 squared plus 6 minus -1 squared. That works out to 1 squared plus 7 squared, or the square root of 1 plus 49, which is the square root of 50. Now keep in mind that we do need to simplify radicals. 50 is 2 times 25, and 25 is 5 times 5. So this is 2 times 5 times 5. If I circle the pair of 5s and bring that out, I'm going to have 5 times the square root of 2. So the length of this side is 5, hold on, from P to Q. I feel like I made a typo here. I might have gone too fast. From P to Q, 3 minus 2 squared, and then 6 minus negative 1. That should be good, square root of 50. So I'm getting 1 squared plus 7 squared, which is the square root of 50. I think it's fine. I was thinking for some reason that we were going to be able to combine like terms, but I don't think so here. All right, so this is going to be 5 radical 2. Now, to find the length of OQ, let's just do Pythag. If we do Pythag, the length of this side of the triangle is 3, and the length of this one is 6. We would do 3 squared plus 6 squared equals OQ squared, or 9 plus 36 equals OQ squared, or 45 equals OQ squared. If we take the square root, we get from O to Q is the square root of 45. Now again, we want to pull out any pairs. 45 is 9 times 5. 9 is 3 times 3. So I got 3 times 3 times 5. I take out that pair of 3's, and I have here 3 radical 5. So we can see that this length is 3 radical 5. All 3 sides are different. So if all 3 sides are different, how would I classify this according to its sides? Would it be scalene, isosceles, or equilateral? It would be scalene. So to classify by its sides, we want to say scalene. Now, there was a part 2 to this question, and again, this would be on an A level on a test, is to say whether or not this is a right triangle. So we want to look and see if these 2 lines right here are perpendicular to each other. If it's a right triangle, then those 2 legs would have to form a right angle. What we would see happen then when we found their slope is that their slopes would be opposite reciprocals. The sides would be perpendicular to each other. The slopes would be opposite reciprocals. So let's see if we get that or not. I'm just going to count out the slope for you guys. From P to Q, I would go down 2 and over 1. So I'm going to write the slope of PQ is negative 2 over 1. Then, to calculate the slope from O to Q, I would go up 1, 2, 3, and over 1, 2, 3, 4, 5, 6. So the slope of OQ is 3 over 6, which reduces down to 1 over 2. So you tell me, are these 2 slopes opposite reciprocals, yes or no? One is positive and one is negative, so they're opposites. And if I flipped 1/2, I would get 2 over 1. So they're reciprocals. So we know that these 2 segments are perpendicular to each other, which means they do form a right triangle. So this would be a scalene triangle if we classified by its sides, and a right triangle if we classified by its angles. All right, good job, guys. That's it for the notes on this section. Bye.